Hi and welcome back to my channel. Today you'll learn what AES encryption is, how to use it in C#, and some quick do's and don'ts to keep your code safe and clean. We will generate a short tool where you can store your passwords in a safe and easy way. So let's jump in this topic. So the first question is, what is AES? I stands for Advanced Encryption Standard. It's like a digital safe that locks your data with a secret key. You feed it plain text, like your password, and it spits out encrypted text called ciphertext. Only if you have the same key, and the initialization vector, can you unlock it again. If your key is wrong, or your 4 is different, decryption fails and you'll get gibberish or an error. Here are some do's and don'ts that you get a feeling for it. But we will dive not too deep, just the basic is enough for the moment. I would say, let's take a look at what something like this might look like. First, let's take care of a small user interface. Basically, we only need a few text boxes and buttons, as well as a DataGridView for visualization. As always, you are free to create your own layout, as we are only dealing with the basics here. Maybe a short fun fact until the UI is finished. ICE was actually selected by the U.S. government in 2001 after a global competition. It's so strong that it's used worldwide for securing banking transactions, military communications, and even your encrypted Wi-Fi. I will be back in a moment to write the actual code. Looks pretty good, doesn't it? Next, we'll create a small helper class to make the whole thing a little more user-friendly. I'll explain the code after creating all the classes. See you in a moment. Let's take a closer look at how this encryption method works, step by step. During the coding we needed also to add a NuGet package for NewToneSoft first. We define a few important fields at the top of the class. This is just the file where we'll save all the encrypted data, like a mini vault on your computer. Now here comes the secret sauce. These two lines define the key and the fourth, or initialization vector. We convert our string values into byte arrays using encoding UTF-8 get bytes. Think of the key as the password to lock or unlock the vault, and the fourth as an extra safety twist that makes sure each encryption looks different, even if the input is the same. And don't forget, use exactly 16, 24, or 32 byte keys for ICE 128, 192, or 256. The fourth length in bytes is always 16. Now the encrypt method itself. This creates a new AES object and assigns it our custom key and 4. Without these, AES won't work, they are mandatory. We create an encryptor, a tool that knows how to scramble our plain text using AES. Then we create a memory stream, basically a space in memory where we store the encrypted result. Now the magic begins. Here's what's happening. We wrap the memory stream with a crypto stream, which handles the encryption. Then we write the plain text into it, and it gets encrypted on the fly, automatically. The encrypted data is still binary, so we convert it to a base 64 string, that makes it readable and easy to store, for example in a file or database. So, in short, we take plain text, run it through AES using a key and 4, and return a nice encrypted string we can safely save. That's the encrypt method, simple, secure, and works like a charm. Alright, now that we know how to encrypt text, let's walk through how we decrypt it, meaning how we turn our scrambled ciphertext back into something readable. Let's break it down step by step. This method takes a string called ciphertext. That's the encrypted text we want to decode. Just like before, we start by setting up AES. We're creating a new ICE object and assigning it the exact same key and 4 that were used for encryption. If the key or 4 don't match, decryption will fail, or return garbage. This is our special tool that knows how to reverse the encryption. Now, remember, our ciphertext is in base 64 format because we converted it during encryption. So we decode it back into bytes first. Then we prepare to read it. This is like loading the scrambled data into a memory box. Now we build the pipeline to decrypt it. We wrap the memory stream in a crypto stream, and then use a stream reader to read from it, and as we read, the data is decrypted on the fly. This line simply reads and returns the fully decrypted, original plain text, so we reverse the encryption steps, decode the base 64, decrypt the bytes using AES, and return the readable result. Simple. Powerful. And it keeps your password safe and sound. Now let's take a quick look at the heart of our password vault, the vault entry class. This class is a super simple data container, also known as a model, and it holds the 3 main things we want to store for every password entry. Service, this is the name of the app or website, like Gmail, Netflix, or Instagram. Username, the email address or username you use to log into that service. Encrypted, password, this is the ICE encrypted version of your actual password. We never store the plain password directly, only the encrypted version, which keeps things safe. That's it. Just 3 properties, all strings, that together make up a single password record. And when we save multiple of these, we're building up our full password vault behind the scenes. Simple, clean, and perfect for storing encrypted login data securely. Alright, let's now take a look at how we actually store and retrieve our encrypted data, because encryption is useless if we don't save the results somewhere, right? This method takes a single vault entry, which includes a service name, username, and encrypted password, and adds it to a file on disk. Let's go through it line by line. First, we call load entries to get the current list of saved entries, so we don't overwrite anything. Then we add our new entry to the list. Finally, we serialize the entire list to JSON and write it into a file named vault.json. The indented formatting just makes the JSON nicely readable, for debugging or curiosity. This method reads and returns all the saved entries from the file. Here's how it works. If the file doesn't exist yet, for example, the first time the app runs, we simply return an empty list. Otherwise, we read the file, deserialize the JSON back into a list of vault entry objects, and return that list. This means we instantly have access to all previously saved encrypted passwords. That's in general all in this class. Now let's jump to the main class and use it. We'll see you after setting all up. Alright, let's now take a look at how the user interface actually hooks into our encryption system, starting with the Form1 class. At the very top, we create an instance of our password, vault, class. This gives us access to all the encryption and file saving methods we've written, like encrypt, decrypt, save entry, and so on. Now comes the important part: what happens when the user clicks the encrypt and save button. This method runs when the user presses the button in the UI. Inside it, we create a new vault entry object. We take the values the user typed into the form, the service name, the username, and the password. Then we run the password through our vault encrypt method, so it's fully secured before we save it. We pass our entry to the vault, and it gets saved into our vault JSON file using the logic we built earlier. Then we show a quick message. This confirms to the user that everything worked. And finally, we clear the input field so the form is ready for the next entry. So what's happening in total? The user enters their login info. They click encrypt and save. The password gets encrypted using ICE. The entire entry is saved to disk. And the form resets for the next input. Nice and simple, but super powerful under the hood. Let's now take a look at how we can view all our saved passwords, and how to decrypt a specific one when needed. When we click this button, it calls the load entries method from our vault, which reads all entries from the vault JSON file. Then we bind that list to our DataGridView, so the entire vault is displayed right inside the app, one row for each service, including the encrypted password. It's a super quick way to load and view everything you've saved. This method is triggered when the user clicks the decrypt selected button, for example, after selecting a row from the list. First, we check if the user has actually selected anything. If nothing is selected, we simply return, we don't want to crash or decrypt error. Next, we get the encrypted password from the selected row. Here, we're grabbing the value from the encrypted password column of the selected entry. Then we decrypt it. We pass that encrypted string into our AES decryption method, and get the original plain text password back. Finally, we show it. This gives the user a quick look at the decrypted password in a message box. So in short, show all loads and displays all saved vault entries. Decrypt lets us select one entry and instantly decrypt the password behind the scenes. It's simple, intuitive, and it works like a charm. And that wraps it up, our own lightweight password vault tool built in C# with WinForms and AES encryption. Let's quickly test it one more time to see everything in action. Let's quickly recap what we just built. We learned how to encrypt and decrypt passwords securely using AES in C#. We created a simple UI with text boxes, buttons, and a grid. We wrote everything to a local JSON file, and loaded it back in any time, and we kept our data secure by never saving plain text passwords, only encrypted ones. Share your feedback. This tool is meant to be a basic starting point, to help you understand how encryption works and how to structure a real-world style app. If you want to take this further, for example, add a master password or login screen. Store entries in a real database. Add search, copy to clipboard, or autofill. Or turn this into a more practical daily use app. Let me know in the comments. I'd love to hear your ideas, and I'll make a follow-up video based on your feedback. If this video helped you out, please consider giving it a thumbs up. Subscribe for more beginner-friendly WinForms and C# tools. Thanks for watching, and see you in the next one.